Okay, so what we're going to do now is establish a rule for calculating conditional probabilities. We're going to go back to our table that we had created in 5.3, where we had a homeowner, not a homeowner, whatever you like. You have high school graduates and not a high school graduate. We're looking at people that own homes that also graduate from high school. All right. So, So let's calculate a different probability. All right. Let's figure out the probability of a person. Right. So let's word it this way. If we know that a person owns a home, what is the probability the person is a high school graduate? Okay. So what we're saying is, okay, what we're actually asking is, what is the probability probability that they are a high school graduate, and we use the word given. I'm going to underline it in this case because that's the main operative word here. Given owns a home. This is the probability rule. So, what happens is we're really actually only interested in this line at that point, right? We're only interested in looking at homeowners because of this word given, right? Given they own a home, what's the probability that they're a high school graduate, right? Another way to say it. So we see this number, right? Yeah, those are homeowners who are high school graduates, right? But we're only interested in the set of people who own homes in this case, right? So we're not looking at, so our total sample size is not 500, right? Our sample space is not 500, right? It is 340. So that's what's changing, right? So this probability is going to be equal to 221 out of 3. Okay, and let's do another one. And also, we can use this notation for this, right? So we could say that this is the probability of a graduate given, okay, that's what this line means. This line means given. So let's do things in this thing. So we can use that notation. Probability G given H. That's how you say that. Probability of G given H. Alright, I used up a massive amount of space with that little bit there. We do need to find another conditional probability. So I'm going to go ahead and have this scroll over here. I'll have to go down, go back up and look at our list. So 2, let's look at the probability that they own a home, owns a home, given they are a high school graduate. It's a little different. Right, this is the probability of H given G. Okay, well, let's check it out. So we're looking at, so given high school graduates, so that means that we're only looking down this row, right? Because we're only interested in people that are high school graduates. Yeah? So homeowner given high school graduate is going to be, all right, we're still interested in this 221 that I had circled. But now our total, our sample space is going to be 310. So that is going to be equal to 221 divided by 310. Okay, so it turns out that there's another way to do this. So if I wasn't given this table and I was only given some probabilities, it turns out that there is a formula, and it's a new formula that we'll use. And we'll actually calculate each of these probabilities both ways. So we're going to use the formula. And we're going to, so we've already used the table. Let's now use the formula. So our formula is going to be the probability of A given B is going to be equal to the probability of A intersect B over the probability of B. And you can, likewise, you can switch it, right? If I have the probability of B given A, that's going to be the probability of B intersect A divided by the probability of A. Okay. What did we say that this intersect was? Is it or and? All right, so let's calculate each one of these probabilities. Okay, so what is the probability of A intersect B? That's probability A. A and B, right? So that is going to be, right, we're looking at the probability that they're a high school grad and they own a home. So where is that? High school graduates and homeowner is 221 out of 500, right? Perhaps that was just given to you as a probability, which is normally what's going to happen. If you're going to use these, this particular formula, you're going to be given a set of probabilities and you have to apply it to the formula. So I'm going to go ahead and write that proportion as a decimal. That is exactly 0.442. And what is probability of, sorry, I use these A's and B's. I'm sorry about that. Sorry, I want to change these to G's and H's. Sorry. I was looking at my formula and I wrote down the same letters in the formula. We're applying this to this actual case. So this should be G and H and G and H, right? G and H over probability H. Alright. And what is the probability of H? Probability that a person owns a home. So all homeowners, there are 340 of them, right? 340 homeowners. So that probability is 340 over 500. Which is going to be exactly 0.68. All right, darn it, I wanted to have this all in one spot. Because I wanted to now apply that to this formula, right? So, sorry, I'm going to have to scoot this down here. Sorry about that. I'm working this down here. Because I want to do now the probability of G given H. And I want to work it just using the formula, okay? So, the probability of G and H, or G intersect H, and I'm going to write that probability of G intersect H over the probability of H. This is one I constantly wind up looking at the formula for, because order matters. Okay. All right, so now we can plug those things in. What we should do is we should get this, right? Oops, it might not be a present. Okay. $221 divided by 300. Approximately it is approximately 0.73. We should get that, right? These should be the same probability. Calculating it from the table and from the formula. Okay, so I need all those things. There we go. So the probability of G intersect H is 0.442, and probability H is 0.68. Let's see what we get. Magic time. Huh? Alright, this is supposed to be 310. I don't know where I got 300. I guess I was obsessed with the movie involving war and ripped abdominal muscles. Right? That's what that movie's about. I'm pretty sure. But I'm still getting the result. It is approximate. Alright, sorry, I made a typo, and then I went to fix it. When I wrote the 300, I fixed it incorrectly. This, I know you erased it a bunch of times. It's supposed to be 3. Not sure why I wrote 300. That is 0.65 exactly, actually. And right, that makes sense. Probability that you're a high school grad given you own a home. So we're only looking at owning homes, which means that this right here is our sample space. Okay, Sorry about that. And it turns out that when you calculate this, you get 0.65. Okay, let's do it again. Far more successful. Right? So I'm going to go ahead and sequester that. It lives up there. Let's do the same thing with this one. So we should use the formula, and we should be able to get 221 divided by 310 is approximately 0.713. All right, and now we should be able to roll with this thing, right? If we use our formula, the probability of H given G, the probability that a person graduated from high school, is a homeowner, can't say that word properly, given that they graduated from high school, it should be the same thing as the probability that they graduated from high school, that they're a homeowner and graduated from high school. Sorry, the H is making me think high school. Divided by the probability that they graduated from high school. All right, so we're going to calculate what the probability is. We're going to calculate the probability of H intersect G, or H and G. So a homeowner and a high school graduate. High school graduate and homeowner is 221 out of 500, right? It's the same. It should be the same as the probability that you're a graduate and a homeowner, right? It doesn't matter, right? Probability G intersect H is going to be the same thing as probability H intersect G, right? It's the same. Yeah? So that's going to be, what was it, 221 out of 500? We've already calculated that up here. That is 0.442. And then we've also, we've not calculated the probability G yet. We calculated the probability G. So the probability that a person is a homeowner is going to be 340 out of 500, right? We already did that. Except for that's not the one we want, right? Sorry, we want this one. And I'm trying to calculate probability H. Probability G. Sorry about that. Probability G. So probability of a high school graduate is going to be 310 out of 500, right? So here's our proportion. I'm going to calculate that using my handy dandy calculator. Which is exactly 0.62. So then, we should be able to calculate 0.442 divided by 0.6 to get a desired outcome. I'm not sure if it's a precise answer, so we'll wait on that. 0.42 divided by 6 is 6. Not sure. Everything's right. I think there's a rounding issue going on with our fractions. Because those things should be the same. Huh. Interesting. I don't see anything. I don't see any error there. So I'm assuming that there's, because we have so many fractions going on. I think that if I went ahead and put the fractions in there and calculated it that way, I think it would be an exact answer. All right. Cool. So moving right along. New table. We're looking at phone usage. So I got a two-way table. I have a landline usage versus people that don't have a landline. Do you guys have landlines? I don't have a landline. And a cell phone. And no cell phone. Total. And then over here we'll have a total. So assuming they took a survey of people and asked, do they have a landline? Do they have a cell phone? And all of that. There you go. So let's look at it. So 0.51, those are people that both, so the probability that a person selected at random has both a landline and a cell phone. These people are like me. They have no landline and a cell phone. The total probability here should be 0.9. Just real quick, let me ask this question. What number should be there? 1. Yeah, it should be 1, right? If this is a legitimate probability, all of these should add to 1. All right, 0.09 here, 0.02. There will be a question like that on the AP exam, guaranteed.
What?
That they want you to know that that's a rule of probability. They'll, of course, word the question in a tricky way, but the answer is going to be interpreting that a rule of probability is that they add up to 1. I shouldn't say there will be. I shouldn't guarantee it. Chances are. For some reason, they have perused many AP exams, and there's usually one in there that has to do with that. All right, so let's find the probability that a randomly selected household with a landline also has a cell phone, okay? All right, what is the probability that are randomly selected households, right? With a landline. So, that's the way this type of question will be worded. Yeah. That's how you would word that type of question. So you have to interpret what they're asking, right? Are they asking for the probability that you would randomly select a household and they have a landline and a cell phone? So we're really only concerned with the ones that have a landline, right? In this case, so that's different than the probability that they have a landline and a house and a cell phone. What we're looking at is the probability. Yeah, the probability that they have a cell phone, given they have a landline. Huh? Yeah. Yeah. So probability. So let's call probability. No, it's C given. So we'll call it probability C that they have a cell phone, and probability L they have a landline. So that is going to be the probability of C and L over probability of L. Alright, so what is the probability that they have a landline and a cell phone? That's this one right here, right? And this is more commonly how you'd be given this question. And then the probability that they have a landline. Yeah. So in this one, right? This one is the probability that that you have a landline. Yeah. So this one I should circle, which is going to be equal to exactly 85%. Boom. All right. We have a cool new rule that we're going to learn. Yay! We're going to learn our general multiplication rule. Okay. So if we want to know the probability of A and B, and by the way, I like to use the ampersand because it's used more commonly in logic. It's actually, it's the symbol that means and in mathematics. Okay. That is going to be equal to the probability of A intersects B, right? Sorry, it's kind of redundant. That's the probability of A times the probability of B given A. Okay. Yay, new formulas. This guy actually is not on your AP exam formula sheet. The other one is. But it's pretty easy to derive it, right? You know what I'm saying? So if you're given, you do get this one, the probability of A given B is equal to the probability of A intersect B over the probability of B, right? If you wanted to know the multiplication rule, right? All you have to do is multiply both sides by probability B, right? And of course, those are going to cancel because they're 1. And you wind up with your rule, right? Probability B times the probability of A given B is going to be equal to probability of A union. Cool. So if you're looking for the multiplication rule and you forgot it, you can go to the conditional probability rule and figure it out, right? Because luckily these things follow rules of algebra. So that's good news. Cool.